All right, page 642, number 1. It gives us the masses of the proton and the neutron. They're the same as what we used in the example. And it says a carbon isotope, carbon 12, has a nuclear mass, so it's carbon 12, and that's important because that tells us how many protons and how many neutrons. And the mass of its nucleus is 12.000, because that's the defined one, remember? We define an atomic mass unit to be 1/12 of a carbon 12 atom. Therefore, carbon 12 is going to have 12 of them, and it's going to be exactly 12. So our mass defect, or our delta M, will be the mass of our nucleus minus brackets the sum of the masses of our neutrons plus the sum of the masses of our protons. So our delta M will be 12 U's minus bracket. There's 6 protons, so 6 times 1.008665 plus, and there's 6, I said 6 protons and I wrote neutrons. Sorry, 6 neutrons and 6 protons. 0.007825. Close the bracket. So delta M is equal to 12 U's minus, you get 12.09894 when you do the bracket. And so then when you subtract, you get a negative 0.09894 U's, where of course the negative means mass is missing. That's part A. Part B wants binding energy. And so we know binding energy is equal to the delta M times 931.4, I lost my 1.48 mega electron volts per U. So the binding energy is going to equal, and I drop my negative here, 0.98944, because we know what it means. It just means mass is missing. There's only 1 4 there. I just can't see in the light. U's times 931.48 mega electron volts per U, and you should get a binding energy to be 92.1606312 mega electron volts. Okay, number 1. Number 2 is exactly the same thing, only it's with a hydrogen isotope. This time it's hydrogen 2-1. And it says that its mass of its nucleus is 2.0140 U's. So again, our delta M is equal to the mass of our nucleus minus the sum of all the masses of our neutrons plus the sum of all the masses of our protons. So our delta M is 2.0140 U's minus, there's only 1 neutron, so 1.008665, and there's only 1 proton plus 1.007825. Delta M equals 2.0140 U's. When you do the math inside there, 2.01649. And so your delta M becomes negative 0.00249 U's. That's our mass defect, where of course this means missing. And now to do our binding energy, exactly the same thing. Binding energy will equal delta M times the 931.48. Your textbook has 49, but the more accepted value is 48. But if you use 49, just means your answers will be a tiny little bit different from mine, but not too much. Okay, and so then this is going to be times the 931. Keep losing that 1.48 per U. And so you get a binding energy. I don't know if it's me or my thing, but that doesn't look clear to me. You get 2.3193852 mega electron volts. Not nearly as much as what you would have had in carbon, which makes sense because carbon was much bigger. There's only one proton and one neutron here, so you shouldn't need as much binding energy as you did for the carbon. All right, the next one is nitrogen, and it's nitrogen 15. So number 3. So it's 15, and nitrogen's atomic number is 7. And it says its nucleus's mass is 15.00011 U. So again, delta M is the mass of the nucleus minus brackets the sum of the masses of the neutrons plus the sum of the masses of the protons. So delta M is equal to 15.00011 minus brackets nitrogen 15, so there's 8 neutrons, 1.008665, and there's 7 neutrons, other way around, 7 protons, 1.007825. Even though my words aren't matching, my numbers are the right way. So there's 8 neutrons and 7 protons. Delta M is equal to 15.00011 U. When you do the inside the bracket, you get 15.124095. So of course, again, you get a negative because there is mass missing of 0.123985 U missing. Okay, and then binding energy is going to be the delta M times the 931.48 mega electron volts per U. So 123,985 U times 931.48 mega electron volts per U. And you should get a binding energy of 115.4895478 mega electron volts. Again, it should be bigger than even the carbon because nitrogen 15 is bigger than carbon 12. And the last one, number 4, is oxygen 16. So 8 and 8. And it is 15.99491 U. Delta M, mass of the nucleus, minus the sum of the masses of the neutrons, plus the sum of the masses of the protons. So 15.99491 minus, and it's 16, so it's 8 and 8, so 8 times 1.008665 U plus 8 times 1.007825 U. Delta M equals 15.99491 minus 16.13192. And you should get a delta M again to be negative 0.13701 U. Where again the negative means missing. And one more time, exactly like the last ones, binding energy will be equal to delta M times 931.48 mega electron volts per U. So 0.13701 U times the 931.48 mega electron volts times U, and you should end up with a binding energy of 127.622 mega electron volts. Again, bigger than the nitrogen, because oxygen has a bigger nucleus because it has 16 and nitrogen only had 15. All right, so hopefully these are pretty straightforward and good.